You're watching VTN, where news don't matter. Hackers all around the world are doing anything they can to get a hold of your personal information for their own beneficial gain. You see, by going on these websites that you do every single day as a routine, are you safe from them? DNS cache poisoning certainly do not make you feel safe anymore now, does it? On the air, we have Professor Handa Yomomata to help us with understanding what exactly is DNS cache poisoning. Hi, Professor. How are you?
How you doing?
Thank you for joining us on VTN today. So exactly, what is this DNS cache poisoning? Yeah, DNS cache poisoning is very simple and pretty straightforward. For example, the most simplest way we do on the internet is we check news, do our online banking, stuff like that, even checking our emails. Now, when you type into websites or anything like that, what happening in the background is basically involved DNS server to another DNS server. Well, DNS server A, which is the one on your internet service provider, controls a certain about IP addresses that we know, which is the cache. Some of the things that we go all the time, like Yahoo.com, things that we go on and on, will basically be stored in the cache. Now, what's stored in the cache is IP addresses that goes to those websites. Now, let's say you've been to a website you've never been to before, and it doesn't have that information, or it doesn't control that domain. What it does is send a request to another DNS server, or going to DNS server after another, the one that do have the information. Now, once we get to that DNS server, it sends back that request and replies to that this is the IP address. We have experts who are continuously working on it and see how that really works. Now, Yahoo.com, for example, wouldn't be necessarily Yahoo.com. It would be the IP address. What hackers are doing are taking the DNS server and actually uploading and poisoning it with their own IP addresses that will go back to their DNS server rather than the one that you intended to. For example, they might change websites like Yahoo.com, your email, or your bank website. It'll be a total different one. When you log in, it basically won't go to the original website, but it'll go to the website that is hosted on their server at that new IP address, which is considered poison. The DNS server has been poisoned with that information. Our experts basically set up a Johnson & Wales email. Our experts basically take this stuff and do it. Our team of experts are working night and day to make sure this is getting working down so you can understand how exactly does it work. We take DNS cache poisoning and we point it over and over and over. We set up our own hacked DNS server in a stimulated environment at the networking lab. By taking this networking lab, we will stimulate a working Johnson & Wales email account and website and make it look like the actual real thing. Students at Johnson & Wales will basically normally check their email all the time because it's the university's main line of communication. Changes of grades or any updates based by university is always sent by email rather than by phone or by mail, whether you're paying your bill and stuff like that. So we basically recreated the website and added the new coding. Looking at it, we need to figure out how exactly does the user input his information and where exactly does it go to. In this case, if a hacker was to be poisoning it, they would change the IP address to go to its own. In this case, we added several new lines of codes to the HTML source. Now we added an extra line of code besides changing the IP address. Not only are they going to still continue to go to their email, however, whatever they type in username and password, once they click submit, not only will they go through their email normally, that extra line of code we added basically go to our side, our database, where we can just pick it up. With this side, we're entering the username, then the password. Notice how it works? Well, looking on the right side, we're going to update our database and see that whatever that person typed in is now in our database. See? We just got a hold of your username and password. Now in Wireshark, what we did was capturing what we just did right there. Now this is just basically your download email. It can't do a whole lot of damage just by spamming and other stuff. But if this was an actual bank website or a something that's more dangerous, like a shopping account or something like that, it could do a whole lot more damage than that. Thank you, Professor, and I appreciate your time. Hope to talk to you soon. This is VTN, and thank you for watching.